Hey everyone, and welcome to this explainer. Today we're unpacking one of the most fascinating, yet kind of invisible, layers of our digital world. We're going to completely demystify exactly how instant communication actually works on the internet. I mean, have you ever stopped to wonder how a message pops up on your screen the exact millisecond your friend hits send? Well, let's get right into it. So I want you to imagine, just for a second, the absolute frustration of playing a fast-paced multiplayer video game, but with a massive catch. The screen only updates to show where the other players are when you manually click a refresh button. You'd be totally defeated before you even knew what was happening, right? But thankfully, you don't have to hit refresh. When a player on the other side of the world jumps, you see them jump instantly. So how is the internet, which is just this massive global web of wires and servers, pulling off this real-time illusion? Well, the secret behind this magic is a remarkably powerful technology called WebSockets. While you're out there browsing, clicking, and gaming, WebSockets are basically acting as the unseen superpower that makes our modern, real-time internet possible. They're the backbone of everything from live chat to real-time stock tickers. But to really appreciate how groundbreaking WebSockets are, we first kind of have to understand the old way the internet used to talk to itself. Okay, let's dive into this. To make things super clear, we're going to use a really simple analogy. Think of traditional internet communication, which is known as HTTP, kind of like sending physical letters in the mail. It's super reliable, sure, but it takes time, and you always have to wait around for a reply. WebSockets, on the other hand, they're like handing someone a two-way walkie-talkie. The difference in speed and how you actually interact is literally night and day. Let's look a bit closer at that sending a letter method, traditional HTTP. When you go to a website, your computer sends a request, a letter, to the server. It says, "Hey, please send me the homepage." The server gets the letter, packages up the homepage, and sends it back. But here's the absolutely critical part. As soon as the postman delivers that reply, the connection completely shuts down. The transaction is 100% over. If you want any new information, you have to write a brand new letter and start the whole waiting process all over again. Now, what's really interesting is how developers used to try to fake real-time updates using this incredibly slow postal system. They used a technique called HTTP polling. Imagine being on a long road trip with a kid in the backseat who just keeps asking, "Are we there yet?" every 5 seconds. No. Are we there yet? No. That is exactly what HTTP polling is. The browser asks the server every 5 seconds, "Do I have a new message?" And usually the server just says, "Nope, no new messages." It's wild because this wastes a massive amount of internet resources and server power, literally just asking questions when there's zero new information to give. And this is exactly where WebSockets swoop in to save the day, introducing a concept known in the tech world as full duplexed. Now, you can totally forget the jargon. Full duplex just means a two-way walkie-talkie channel where both sides can talk and listen at the exact same time. No more waiting days for the mail carrier, and no more annoyingly asking, "Are we there yet?" every 5 seconds. So the absolutely crucial point here is that with WebSockets, the connection stays open. Once you turn on that walkie-talkie channel with the server, you keep your finger on the button. If a new message comes in, the server doesn't even have to wait for you to ask for it. It just pushes the update instantly, right through the open channel, directly to your screen. It is an ongoing, completely continuous conversation. Let's really lock this concept in by putting these two methods side by side. HTTP connections are short-lived, whereas WebSockets are persistent. HTTP is a strict wait-your-turn request and response model, but WebSockets are full duplex, meaning everybody gets to talk at once. Because of all this, traditional HTTP has higher latency. It's just slower, making it pretty poor for real-time needs. Meanwhile, WebSockets boast very low latency, which makes them absolutely excellent for anything that needs to happen right this very second. Now, this brings up a fantastic question. Browsers fundamentally speak that older HTTP language, right? So how exactly do we convince the internet to drop the slow letter-writing routine and suddenly switch over to an open, high-speed walkie-talkie channel? Well, the answer is this brilliant little technical dance called the WebSocket handshake. It actually starts out as a regular, old-fashioned HTTP letter. Your browser sends a message to the server saying, "Hello, I'd love to talk, but instead of sending letters back and forth, can we upgrade to WebSockets?" If the server agrees, it responds with a special code that basically says, "Sure thing, switching protocols now." It's exactly like two people with walkie-talkies agreeing to tune to the exact same frequency right before they start talking. Let's see how this all builds into the complete life cycle of a WebSocket connection. It's actually elegantly simple. First, you connect, you turn the walkie-talkie on. Then, the connection is open, meaning you've successfully tuned to the right frequency. Next comes the main event, send and receive, where data flows freely back and forth. And finally, when you leave the website or close out the app, you hit close, turning the walkie-talkie completely off. Now that we understand the incredibly clever how of WebSockets, let's totally shift gears and look at the where. Because having an open, instant communication channel gives our favorite everyday apps what essentially amount to real-world superpowers. Seriously, think about the apps you rely on every single day. When you're typing in a live chat application and you see those 3 little dots showing someone is typing back, that's WebSockets. Live stock market updates flashing green and red every fraction of a second? WebSockets. Live map tracking showing exactly where your food delivery driver is on the street? Yep, you guessed it, WebSockets. Even collaborative editors, where you can literally see your coworker's cursor moving across the document in real time, all of it is powered by this exact same persistent, instant connection. And you know, this brilliantly illustrates the online gaming scenario we talked about right at the very beginning. Imagine player A is sitting in New York and player B is over in Tokyo. Both of them have an open walkie-talkie connection to the game server. Player A moves their character to the left. That command shoots up the open channel to the server, and the server immediately shouts down player B's open channel, update screen, player A move left. It literally happens in milliseconds. Perfect synchronization, absolutely zero refreshing required. But of course, in the real world of global internet giants, things are rarely that simple, are they? A huge new challenge arises: scaling. What happens when your game goes viral or a massive news event breaks, and suddenly you don't just have 2 people talking, but 10,000 or 1,000,000 people trying to use these open walkie-talkie channels at the exact same time? See, a single computer server acting as the host for all these WebSockets is kind of like a single dispatcher trying to manage thousands of incoming radio calls simultaneously. No matter how powerful that server is, eventually it just runs out of memory and processing power. The dispatcher gets totally overwhelmed, the lines get crossed, connections start dropping, and that real-time magic completely falls apart. So, to solve this, enterprise software engineers don't just build infinitely bigger servers. They use teamwork. They bring in specialized tools to help a whole network of dispatchers manage the load. They use things called load balancers, which act like traffic cops, pointing new users to the least busy server. They use tools like Redis, which acts like a giant megaphone, allowing server A to instantly share a message with server B so everyone stays in the loop. And for truly massive data, they use systems like Kafka, which are basically high-speed, multi-lane highways designed strictly for routing millions of messages globally without a single traffic jam. By combining WebSockets with these incredibly powerful scaling tools, companies create an architecture where millions of individual walkie-talkie connections can stay open at the exact same time. The traffic cops distribute the load, the megaphones keep all the servers talking to each other, and those high-speed highways ensure that no matter where you are in the world, your data is fast, open, and completely in sync. So we've journeyed from the slow, waiting game of the traditional postal service to a world of instant, global, two-way walkie-talkies that can scale to handle millions of users effortlessly. You now truly understand the hidden architecture that makes the modern web feel so remarkably alive. Now that you know the secret of how the internet actually talks instantly, the only question left is, what incredible real-time application would you invent? Thanks for joining me on this explainer, and definitely keep staying curious.